Okay, so let's just quickly cover piecewise functions, all right? So if I have the function f of x equals x squared from x less than 0, less than equal to 0, and then I have x when x is greater than 0, okay? Now, how would we evaluate the limit as x approaches 0 of f of x? So, what we have to do is we have to first calculate the left-hand side limit, okay? So, what's the limit as x approaches 0 from the left-hand side of f of x? Okay? So, how do you evaluate that? Well, we have to look at the function specifically when x is less than 0, okay? Because that's what like the left side means, right? Less than 0, okay? So f of x equals x squared for values of x less than 0, okay? So this limit is the same as the limit as x approaches 0 from the left hand side of x squared, okay? Yeah, the function equals x squared when x is less than 0, okay? And now, how do we evaluate this? Well, this is simple. You can just plug in 0 and then you'll get 0. Okay? Now, we have to find the right hand side limit. Okay? So we can apply the same, strategy when solving. Okay? So we'll just say the limit as x approaches 0 from the right hand side of f of x. Well, x is greater than 0, so we'll just say that that limit is equal to the limit as x approaches 0 from the right-hand side of x, okay? How do you evaluate that? Well, you can just plug in 0 and you'll just get 0, okay? So remember, the limit as x approaches 0 from the left-hand side of f of x is 0, and it is also 0 if you approach x from the right-hand side, right? So that means that the limit as x approaches 0 of f of x equals 0, okay? This is the graph of the piecewise function we saw before, and as you can see, as we get closer and closer to 0 from the right hand side, you see that f of x, or in this scenario, y equals x approaches 0, right? And if you approach 0 from the left hand side, the function x squared also goes to 0, okay? So this is like visually how that function looks like, and that's how we can visually prove that the limit equals 0. Okay, so let's practice evaluating composite functions. A lot of composite functions are pretty easy to evaluate, but let's just take a look at this one because there's something that I'd like you to notice that hopefully you'll be able to notice in a few minutes. So we are given a task to evaluate the limit as x approaches 1 of f of g of x, okay? So if we want to use a tabular method, we can plug in values of x that are pretty close to 1, but not at 1, okay? So I'm thinking 0 0.5, 0 0.9, 0 0.99, 1.01, 1.1, and 1.5, okay? So you can use any other values if you'd like. You can use closer values, values closer to 1, but these are just the values that I've calculated, okay? So now, the values that I calculated for g of x are 1.25, 1.01, 1.0001, 1.0001, 1.01, and 1.25, okay? So now, we've calculated g of x, okay? Now we have to calculate f of g of x, okay? So, this is our input, and this is our output, okay? So if you plug in 1.25 into f of x, not 0.5, 1.25, we get negative 1 because that's greater than 1, okay? This will also be negative 1, and everything else will also be negative 1 because all of these g of x values are greater than 1, okay? So you would say that the limit as x approaches 1 of f of g of x is negative 1. Okay, so now we're given the task to evaluate the limit as x approaches 1 of f of g of x, okay? So, first, we can evaluate the limit. First, our first task is to evaluate the limit as x approaches 1 of g of x, okay? So just forget about this for now. Let's just focus on evaluating the limit as x approaches 1 of g of x, okay? Tackle the problem one by one, okay? So, let's see what happens when we get x closer and closer to 1 from both sides, okay? You see that g of x goes up to y equals 2, right? So the limit as x approaches 1 of g of x is 2, okay? Simple enough. Now, if you thought that the next step to evaluate the limit as x approaches 1 of f of g of x, if you thought that now we just have to evaluate the limit as x approaches 2 of f of x, you'd be wrong, okay? Why? Well, if you approach 2 from the left hand right side, right? Left hand side, right hand side, you're going to see that the limit doesn't exist, okay? But there's one factor that you need to take into account. You need to take into account the direction that g of x is approaching 2. So you see that g of x is less than or equal to 2 for all values of x, right? Okay. So that means that if we're plugging in g of x into here, right, we're never going to get any g of x value that's greater than 2, right? So we really don't have to worry about the right hand side limit, right? Because you see it just approaches 2 from below, right? So that's the equivalent to approaching f of x from just the left hand side, okay? So in this scenario only, or not only, but this scenario specifically, the limit as x approaches 1 of f of g of x equals the limit as x approaches 2 from the left hand side of f of x, okay? I'm going to show you a video that I recorded that sort of helps better visualize what this looks like, because this is a little bit confusing. I personally found it a little bit confusing when I first learned it. So you see here, like, if we replay this, here, like, we see that as we get g of x, like, just evaluate g of x normally close to x equals 1, this f of x, it goes up to, you know, it goes up to 2, but then it goes down, okay? So as we go up here, the function goes up. And then as our function goes down to, this point, this function goes down this way. All right, we never even touch this line segment. We're confined to this specific line segment, okay? So that's why the limit exists, and the limit as x approaches 1 of f of g of x, all right, I never actually wrote that, but the limit as x approaches 1 of f of g of x is equal to 2, okay? And the reason why the previous function also only approached -1 was because of the same reason. It's because the function x squared minus 2x plus 2 is always greater than 1, right? So that's why the function f of g of x approached -1. Okay, you just saw that before, but now you were just seeing a visual explanation. But you saw the exact same thing happen with the tabular method also.